All right, I hope it's working. Hello and welcome everyone to today's webinar. Today we'll be looking at and comparing the Shining3D EinScan HX and the FreeScan UE. These two are handheld 3D scanners by Shining3D, and we'll go into some of the similarities and some of the differences these two 3D scanners have. My name is Sven. I am here for the AM Academy from Bayreuth, and I'm glad to have you all here today. We'll have a bit of a Q&A session at the end. Hopefully the chat will not be too far delayed, so I just don't stand here for a minute or two waiting for some questions to come in. And when you finally do ask, I already thought it was over and left the webinar. Other than that, we'll have a recording uploaded later on. It turns out the computer that I'm streaming from is not powerful enough to handle the stream and the scanning process at the same time. This means that I can't have the scanning software spliced into the stream right now. Instead, I'll always have the streaming software on the screen behind me here, but in the recording, I'll be able to edit in some of the software parts, so keep an eye out for that. If you want to stay up to date with any other webinars or streams that we do, please subscribe to the channel, click that bell, like the videos, whatever is done on YouTube or Facebook here, in order to, stay up to date and catch up on everything we do here. Next webinar will be in 2 weeks, also on the Friday, also 10 a.m. And we'll be talking about the Erase3D cloud solution that they offer for their printers and everything connected to them. Right, without further ado, let's jump into this one. I've already mentioned we'll be comparing the HX and the FreeScan UE, both of them handheld 3D scanners. Now, there are a couple of differences between these two that I want to get into right off the bat. First and foremost, the EinScan HX is a hybrid 3D scanner, meaning it uses both visible light and laser light, and you can choose between the two of them whenever you start a scan. On the other side, the FreeScan UE is a pure blue light laser scanner, so no visible light on this one. That is a core difference already. Now, I'm going to get some of the comparisons up on the screen here, and basically what you can already see, there are two different modes of scanning with each of these scanners. So there's a rapid scan and a laser scan with the EinScan HX. The rapid scan being the scan that it does with visible light. And then the laser scan, well, of course, that's going to be a laser. On the FreeScan UE, you either have the multiple scan lines, which is, the general scanning process. That's what you'll usually do. Or you have a single line scan, which is specifically designed to get deeper into pockets or hard to scan places. The scan accuracy, that's really the big benefit of the FreeScan UE, is just far higher. So the EinScan HX on the visible light spectrum goes up to an accuracy of 0.05 millimeters. With the laser, it can go all the way to 0.04. And the FreeScan, this one's the 7, but it also has a bigger brother, the FreeScan UE7. They can have an accuracy of up to 0.02 millimeters. That's just the scan accuracy. The volumetric accuracy is also better for the FreeScan series. The scan speed as well is a little bit increased in the laser scan mode, so about 480,000 points per second on the EinScan HX, and the FreeScan trumps that with its 650,000 points on the UE7, or a whole 1,020,000 points per second on the FreeScan UE7. However, of course, when we scan with lasers, we always need markers on our parts in order for the scanner to realize where it is. Let me go big again. Right here, you have these little markers, and you need to stick these all over the part that you want to scan in order for the scanner to properly orient itself in the 3D space. What else did I have here? Right. Working distance is a bit better, and the depth of field, the maximum field of view. Maximum field of view is actually a big thing, which we might be able to see a bit later on when I scan one of the bigger parts. Because the scanner can just see more, it can scan quicker and you would theoretically need fewer markers to scan the same part. Right. Enough with all of these numbers. Let's actually start in on these scanners. So I'm going to make myself big again, and I'm going to get something over here, because the first step whenever you want to 3D scan is to calibrate your scanners. Now on the EinScan HX, the calibration process would have this board standing upright, and they would give you this little marker to show you how to position the board. And then you would have to scan this board from different angles with the EinScan HX, and then afterwards you would have to put it down flat in order to do a laser calibration and a white balance calibration. Now on the FreeScan UE, this whole process has changed. Instead of doing this, I'm going to take this away now so I don't mess with it. Let me put that behind here. On this one, all you do is you put it down flat, and then you have to scan it from different angles. And because that's different and new, we're going to start off by doing that. One other thing that I haven't mentioned yet is that the FreeScan UE is actually a little bit lighter. So while the EinScan HX weighs about 700 grams, the FreeScan UE only weighs about 650 grams, at least. That's what my scale said earlier. Now, the USB cable that I just plugged it into is basically the exact same as it used to be on the HX. However, there is a different power source and adapter. So make sure if you have both scanners, don't mix the USB cables. Right, I've started the software. As soon as it launches, it should appear on the screen behind me. Then I can start with the calibration, and after that is done, we can actually start scanning an example part. Scanning software always takes a little bit to boot. It gives me a second. Now, if you scan parts that are very difficult to scan, say they have highly reflective surfaces, such as anodized aluminum or steel, or chrome parts, very difficult to scan usually, you can use scanning sprays. And they're either permanent ones, so this is basically just liquid chalk that you spray onto your part and then have to wipe off later on, or you can use sublimating chalk. So this one goes away on its own after about 4 hours. That's always a solution when you have very difficult to scan parts. Right, scanning software is ready, and it theoretically wants to start scanning right away because, well, I calibrated the scanner yesterday, but I want to show how it works. So I'm going to quit the scanning process and go back to the calibration. That's where we are now, and you can already see on the right-hand side of the screen, once again, you get instructions on how to hold the scanner over the board, and this is the area where it tells you how to hold it. You can already see that it's a bit different than with the HX. I'm just going to start. I click on the fast calibration button up here. Okay, so now I need to hold the scanner, and you can see how the blue circle moves and aligns with the green. And then I need to adjust the height so it matches the little squares on the side. And the scanner gives me an audible click every time it is satisfied with one of the positions. And then at the top and at the side, you see the software tell me how to orient the scanner. So I need to be a bit more in the center, keep the green circle, the blue circle aligned with the green one. Come on. And I missed the blue one right there. Okay. So that's the first step. Nope, I didn't. That wasn't good enough yet. There we go. And now you can see I need to angle it a bit to the front. Still stay in the middle though. So about like this, and then of course do the distance again. It's a bit more finicky than on the EinScan HX, if you ask me. But here as well, I'm sure that with some practice, I will get better at this. And Shining3D have already told me that very soon, maybe today, maybe sometime in the next couple days, they will be releasing a software update, streamlining and optimizing not only the calibration process, but a number of other software features, bugs, the scanning drivers, etc. as well. So expect a number of improvements to come along. Come on. Ugh. I seem to be missing that circle. Where is it? Ah, I finally got it. Okay, sorry about that. That took a little longer than it should have. Now we do the other thing in the other direction. So now I angle it backwards a bit. Once again, I need to align the circle and then get the distance correct. There we go. See? That's how easy it could be if I had done it right. Now from the top, once again, I angle it a bit to the right. Always on the right-hand side of the screen, there are the instructions on what it wants you to do. So angle it over a bit. There we go. And now the left side. There we go. There we go. So you can see that that first angle was a bit of an outlier with me really struggling, but overall, normally it's not as difficult. And I'm hoping that this succeeded now and I don't have to do it all over again. And after this calibration finished, very good, and we get the deviation. So that's it with the calibration. I don't need to do a white balance anymore. I don't need to do a laser calibration or anything else, which was necessary previously with the EinScan HX. Beautiful. We've got our scanner calibrated. That means it's actually ready to be used. So I'm going to put this calibration board away as well. And then what I'm going to do is I'm going to get this turntable that we have here with an example part. Now, this one is just, I believe it's brushed aluminum. And it's a part, for example, that is being manufactured in a larger plant. And then for quality inspection, you want to 3D scan it and really figure out where the holes are and whether they're in the correct position, whether they're the correct size, all of these things that sometimes you need to do in quality assurance. So we've got this little fixture here that is 3D printed on top of our rotating plate. And you can see that we've got markers all over the plate and the fixture, but none on our part itself. And this is totally sufficient for the scanner to actually see what is going on. I'm going to start a part. And the benefit of doing it this way is if I keep scanning, you know, this one or very similar parts, I don't actually waste any of the markers because all of these markers are reusable, basically. So this is my UE folder, and that's where I'm going to scan to. Yes. And yeah, for this one, so important to note that the accuracy that I had earlier here on this screen, these 0.02 millimeters for the FreeScan are not the same as the resolution that I set here. This is the point distance. So when it generates a point cloud, the distance between 2 points, that is the resolution. It doesn't really have anything to do with the accuracy itself. So I'm going to stick here to the high detail for now with 0.2 millimeters as the distance between 2 points. That's already very, very detailed. But you know, if QA is my goal, then that is reasonable. So by clicking the button in the center, I can start previewing my object with the markers, and you can see how already on the screen I can see my markers and I can see the laser lines. And if I click the button again, it will actually start scanning the object, and we can see how nice and quick it actually builds the entire model. There will be an audio cue that probably you cannot hear because the microphone shouldn't pick it up whenever I'm too far away, whenever I'm too close. The light on the back of the scanner will also change accordingly. So if something is too close, it'll go red. And if it's too far away, it'll go blue. On top of that, the little center button is glowing red while I am scanning. So if I wanted to scan this a little more, I can just rotate my plate a little bit, make sure the scanner keeps seeing enough of the marker points. And then I just slowly make my way around the whole example part. And the real benefit here is the very high accuracy that you have with the scanner. So for quality inspection, for, well, these, now I forgot the English word. Well, highly accurate digitization of parts, metronomy, that's the word I was looking for. So for metronomy tasks, that's where the UE7 and 11 really shine. That is their prime job, but they're also quite useful at scanning larger parts. So I'm going to scan in a bit on my scan result here, zoom in a bit, and it does look quite nice. I've got all the holes, I've got all the features, and then because I scanned it on top of markers, I can easily cut away everything I don't need by using a cutting plane. I will apply this using the marker, so I'll select that one, and that one back there, and that will create a plane through these markers. And I didn't mean to move it just yet, so I'll move it down. And you can see how now I can move this plane up and down to shave away everything that I don't want to have in my scan. Keep it about there, apply. And after processing, now most of the unnecessary features are gone, and I could actually start, I would have to generate a point cloud out of this, wait a little bit, then I could post-process my scan, then I can export it as an STL file or similar, and then actually have it in a comparison software, such as EinScan Q or VeriSurf or any of these other metronomy solutions. So that's basically the QA part of scanning with the FreeScan UE. So we can see this quite nicely now, how the part actually looks, and then I could, generate an unwatertight model from this, import it as an STL into whatever comparison software I'm using. You can see the surface looks quite nice. And as I said, this is with the high detail, which is what did I have earlier? 0.05 millimeters. So I could have an even higher resolution if I really wanted to. But for my current purposes, it's not necessary. This part would already be quite served quite well as is now. Right. This is something that is entirely possible with the HX as well. However, as I've mentioned previously, this one just has a higher accuracy. And since this task of quality assurance is just something where you want a high accuracy, this scanner would be more suitable to scan parts in this type of situation. Now, that was step one. Let's move on and actually look at something else, slightly bigger. Now, I would love to have more or less half a car in here, because that would be the perfect example. A really big part where you would need lots of markers, where you have dark and shiny reflective surfaces. But sadly, I couldn't fit a car through the door, and not half a car either. So instead, I had to make do with whatever I could find here in the office, which is just, fitting for the recent hot weather is this air conditioner, basically. And you can see I've plastered it with markers. And that's because I also want to scan this one with the HX. And as I said, the HX needs a lot of markers. The EinScan UE, not as many. I will start a new laser scan project, since I don't really need to save that one. And for this one, I don't actually need as high a resolution. The whole thing is a bit bigger. There are no tiny features that I really want to scan, that I really want to pick up on. So the medium detail is entirely fine for me. This one now has a distance between any 2 points that are scanned of 0.5 millimeters. So still quite accurate, but it's not as much as I had previously. What this does do, though, is it massively increases my scan speed. So you'll be able to see now when I take the UE and I start scanning this part, how quickly the model will actually appear. So press the button once, and I will have a preview with my markers on the screen once again. Press the button again, and I will start scanning. And you can see how I can just move around the part and pick it all up just like this. So that's basically the entire backside. Already gotten most of this side as well. Pick up a bit more down here. And then the top. Get this little pocket a bit more. Pick up everything there. Move around the top. And it's just a very smooth scanning experience overall because it is so fast, because it is, well, so easy to do. The scanner weighs next to nothing, and I can just easily hold it in my hand, even at an extended angle above my head without my arm getting very tired, because, yeah, it is that light. And we can see how it nicely picks all of this surface up. And then I'll move around the front. So you can see this, because this is where it gets a tiny bit more challenging. Now, this front is already reflective, but this is where it gets to a black surface. And the normal scan mode will most likely not be able to pick any of that up. Instead, I will have to switch to scanning a black surface. So I'll pick everything up until there. Yeah, up, and you can see how, well, anything that's black is basically, for now, just a big hole in the scan. But that is no real problem. I will simply pause the scan for a second. And then use right here, I don't know whether you can see it on the screen, there's a selection for normal, reflective, and black. And now if I set that to black, I will be able to scan this one. Just continue with it. Once again, start the scan. And now you can see it picks it up quite nicely. So the big difference here, once again, is this is something the HX is also able to do, but the UE, especially at these resolutions, is considerably faster, is considerably more accurate, even at the higher speeds, and it needs fewer of these markers in order to actually generate a full model. So the scanning experience, especially for larger models, is way, way smoother using the FreeScan UE than if you use the EinScan HX. Now this, comparatively, is still a fairly small part. I can scan this with the HX with this amount of markers, no problem. But if I went and actually wanted to scan half or a complete car, well, then the HX will actually be a little bit troublesome. I will need a considerably large amount of markers. I will take a way longer amount of time to do the whole thing, and I'll have to keep waiting, backtracking in order to pick up the markers that I might have missed. This is by far the easier solution if that is actually your task. And we can see how now if I do generate a point cloud out of this, it will take a couple of seconds in order to do this. How nice the surfaces really are on the scan, how accurate everything is. I think I didn't pay enough attention on the back to the QR code. Sometimes the resolution is so good that you can read the QR code in the scan. We'll be able to see if that is the case today, but I think with the resolution I chose, that will not quite be the case. The QR code is just too tiny for that. But everything, all the important features are there. The buttons at the top, the rotor at the front, the shape of the black size, say if that's the part that I wanted to exchange, that's really what I wanted to get out of the scan. All of this would easily work, and I would have this nicely scanned and could import this into any 3D software and then work with it. I'm going to make the camera go up a bit again, so it's not as much of a top-down view. The generating point clouds, of course, always takes a bit. This is also why it is important to choose a resolution that fits your part. Of course, I could have scanned this model with a resolution of 0.05 millimeters. The question is that necessary? And the answer is usually absolutely not. There's no point scanning a model like this with no tiny, tiny features that I want to pick up at that resolution. With a resolution that high, it'll just make the scanning process slower. It'll make the calculation much longer. It'll make your file size huge for no added benefit. I can see everything I need to see here. I have my entire model, and if I didn't like something, for example, there's a little hole over here I could go back into the scanning mode and just pick that area up as well. So I quite like this result so far. You can see even on the back, these are not mistakes on the scanner's side. Instead, that is actually what this mesh on the back side of this air conditioner, what it actually looks like. So it's able to pick up even these slight deformations of a mesh. It's not a solid surface. So I don't know. I'm quite amazed by what this little thing can do and how good the results of the scans actually are. And once again, I'm sad that this is the largest part that I could find to reliably scan because the amazing advantage that the UE7 has really does come out even nicer when you scan a huge model, such as half a car, for example, or engine blocks. Now, one thing that I do still want to mention about the UE, which is new as well, on the EinScan HX, while you were scanning, you had this little UI at the top, and you would have two buttons to zoom in or to zoom out the view on the display, and you would have another two buttons to up or lower the brightness of the scan. Of course, you also had the start and stop scanning button. On top of that, there was an LED ring around the outside that showed you whether you were too close or too far away from the model. Now, they've improved on this UI on the FreeScan UE. On the back, I can show you this as well. There's a start and stop button at the bottom, so that still does what it did before. And then you have the center button, which opens a quick menu. So if you can't get to the mouse and just want a quick menu, you can use this to go back into the calibration process. You can click on fitting view, so it moves the model so you can see the entirety of it. You can delete the scan. You can have you can full screen the scanning application, and all of this works via the back of the scanner. Clicking the middle button once again will activate whatever I've done. So now you can see we've entered full screen mode. One more thing that is also new on this scanner, and I don't know whether you caught it on the comparison. I don't know whether I had it on there. The FreeScan UE7 uses 14 blue light laser lines, meaning it has 7 blue light laser crosses. Now, if I start scanning once again, we can see that on our model. So there are 7 laser crosses that pick up the geometry of my model. The bigger brother, the UE11, has 24, I believe. I'm not entirely certain right now. Apparently, I did forget this, which is not what I wanted. I looked it up earlier today, and now I've forgotten it again. And I apologize. I will look this up later. So it has even more blue light laser crosses. That is how it gets the faster scanning speed, picking up even more points than the UE7, further increasing scanning speed. But what the FreeScan series has as well is a single line scan for pockets and the like. And in order to access it, you just press this middle button a little bit longer, and now I have switched to a single laser line scan, and you can see this on my part as well. There is now just a single laser line, and this is particularly good if you want to get into deeper pockets. That is what it was designed for. It's not the fastest scanning mode, but particularly if you scan, I don't know, an engine block and really need to get into the centers of those cylinders, that's what you can use the single line scan for. It is very accurate, and it is very fine to really get into all those nooks and crannies that are otherwise very difficult to scan. So I think that's most of the things. I apologize if I missed anything. I also apologize if it was too rushed, if I was too quick. If it was the case, you now have the opportunity to ask any questions that you might have. If you want me to repeat anything, go back to anything, redo the calibration, do another scan of this or that part, use the HX, anything you like. Now's your chance to ask for that, and I will do my best to answer any and all questions or do anything that is still necessary to satisfy your curiosity. Again, so my experience so far is the calibration process is a bit more finicky than with the HX, but the scanning experience itself is considerably smoother, is considerably faster, and it's more accurate. However, do keep in mind that the HX is by no means a bad scanner. I could have done this entire model right here with the HX as well, with this amount of markers. It would have worked. It also would have yielded good results. So when deciding which scanner you actually want, it really depends on your specific application. Do you need to scan large models and don't want to use a million markers every time? Maybe the FreeScan UE is the better model for you. Do you sometimes want to scan something of this size and don't mind using a couple more markers and don't need the super high accuracy? The EinScan HX is completely sufficient. If you're looking at quality control and really want to measure where each hole in a part is at a very, very high accuracy, well, once again, you might tend toward the FreeScan UE. So which scanner you want highly depends on your specific application. And if you are unsure which one actually suits your needs a little better, contact us. We'll do our best to help you. We'll do our best to inform you with the knowledge that we have. You can also rent the EinScan HX from us for like a week at a time, so you can try it out for yourself, see whether it is good enough for your specific needs. And yeah, then you can make an informed decision on which scanner you would actually like more. Yeah, I think that's all I have for you today. As I said, we will upload the recording later on. And if there are any questions or comments, please leave them below. I'll do my best to answer these later on as well. So if you later on do remember, oh, I did have a question, just put it as a comment below the video, and I'll answer to that one as well. Other than that, well, thank you very, very much for watching. Thank you for being here today with me. And I hope to see you again in 2 weeks. As I've mentioned, that's when we will go into the race cloud for the Race3D printers. A couple weeks later, we will also have another one of these webinars comparing the EinScan H and the EinScan HX, the two different ones, also both handheld scanners. And then we'll have more and more webinars as time goes on. So do keep an eye out. Do subscribe to the YouTube channel or like us on Facebook, whatever, if you are interested in catching all of those as well. So once again, thank you very much, and I hope to see you next time.